Hello, and welcome back to Part 3 of the 2020 College Football Season Network Profile Summary. Once again, I am Major Andrew Dietz, and we will be using graph theory to explore trends and analysis of the 126 teams in the NCAA FBS division of college football. Here we see the graph of NCAA FBS teams and games played so far through Week 7 of the season. At this point, we see distinct subgraphs developing for each of the major conferences, and while we notice that unlike normal years, some teams have played more games than others, while some conferences have yet to begin their season. Let's examine this graph a little bit further. Remember that each vertex represents a football team and that each edge represents a game played between two teams. The number of edges incident with that vertex is the degree of that vertex. Expanding on this principle, we can infer more information about our graph. The first and most obvious of which is the degree of any vertex represents the number of games that that team has played. But if we consider the edges of our graph as directed edges as opposed to undirected edges, with the source vertex being the winner of the game, then the out degree of each vertex is now the number of games each team has won so far in the season. Using the vertex degrees, we can now examine our graph and determine that there is one team with 5 victories over FBS opponents, that's BYU, and 2 teams with 4 victories each, Alabama and Clemson. But what if we wanted to know more about these teams other than just the number of victories? We can attempt to determine the strength of each team's victories by comparing the in and out degrees of the teams they have each beaten. To do this, we will examine the neighborhoods each team has played. This is to say that if we examine Alabama's 4 wins, we can see their opponents, Missouri, Georgia, Texas A&M, and Mississippi, had an average win rate of .533, while Clemson's opponents only had an average win rate of .437, and BYU's was almost 600. This does not independently mean that Alabama is a better team than Clemson or a worse team than BYU, but that at this point in the season, Alabama's opponents just happen to have a better record than Clemson's. We can also evaluate conferences as unique social networks within the greater society of college football at large. By considering each conference as a subgraph, we determine which conferences have played and won more games by examining the degrees of the vertices in each subgraph and then examining the different degree density for each conference to gain insight on which conferences average more wins than others and which conferences' wins are more widely distributed among the conference member teams. Here we see the distribution of out degrees for FBS teams from 4 of the conferences as box plots. Notice that while the Big 12 appears to have a very normal-looking distribution of wins about the mean, the other conferences all have left or right skewed distributions and outliers which pull their average number of wins up or down. A conference whose distribution of wins are isolated in 1 or 2 vertices might indicate something called a top-heavy conference, a term that is important to many college football analysts. In this plot, the wider middle quantile distribution of the Big 12 may indicate greater parity among the conference's teams, but we will have to let the season develop further data before this becomes useful. Finally, we can examine the impact of the modified season and what it will mean for the conference schedules and the degrees of vertices in the graph. Several conferences, like the SEC and the Pac-12, have elected to have conference-only seasons. This has created isolated components within the graph that has not been common in college football for several decades, and this makes comparing teams from different conferences more difficult and increases the usefulness of creative network analysis. On the other hand, the Big 12's schedule creates a complete subgraph with its every team plays every other team schedule every year. But since they also have non-conference games on the schedule, this is not an isolated component like the SEC and Pac-12, but it will create an induced complete subgraph by the end of the season. In summation, The simple concept of degrees of a graph can provide a lot of insight as to how a graph is connected. In this network profile, we have used the degrees to help determine strength of schedule analysis as well as identify trends between conferences.